I'm going to describe how to use an interactive simulation that shows the fluid velocity in a pipe as a function of the radial distance from the center. So the arrow length in the simulation is proportional to the velocity. The purple boundary here corresponds to the average velocity, and so the average velocity is half of the maximum velocity. The simulation allows you to change the viscosity of the fluid, the radius of the pipe, and the pressure gradient. And then it calculates the volumetric flow rate, this average velocity, maximum velocity, and the Reynolds number. Since this is laminar flow, the Reynolds number is restricted at lower values where we have laminar flow. So let's look at the simulation to see how this changes as we change these parameters. So remember, for laminar flow, the velocity is 0 at the wall and is maximum at the center. If I decrease the viscosity, then the volumetric flow rate and the velocity increases. And notice it says the pressure gradient was reduced as I increased the velocity to keep the Reynolds number below 2100, because that's the boundary where we no longer have laminar flow. So now I can decrease the radius. And now as I decrease the velocity, again we reach that point of maximum Reynolds number. So let's decrease the pressure gradient. The other restriction we replace in the simulation is we keep the maximum velocity at 12 centimeters per second just to keep it on the scale instead of having to adjust the x-axis. And so if I am sitting at that velocity and I start to decrease the viscosity, then what happens is the pressure gradient decreases to keep the maximum velocity at 12. We don't want it to go above 12. I can, of course, go below 12 as I increase the viscosity. In this simulation, the equations that are used are presented in the details. The idea of the simulation is to help you visualize what flow in a pipe is like when we have laminar flow and not turbulent flow.